Alright, based on what you did in the assignment before this lesson start, now you should know that the distance traveled by the waves divided by time, okay, 1 point on the wave, let's say the peak that we used just now, divided by the time taken through a certain distance, okay, then we should get the speed. Alright, so this distance, right, actually if you use it in terms of lambda, okay, in terms of lambda, just now the wavelength is 2 cm, right? So, and you try to look back at that diagram, actually it has about 3 wavelength. So which means that we can multiply the wavelength by the number of wavelength that would be equivalent to the distance that it traveled. Okay, so in that case just now it traveled 3 wavelength. All right, and then we divide by the time taken. So that's basically the other way of doing. Okay, just now we are trying to look at the total distance of this point or the peak that it moved across. Then after that we divide by the time that we measure. Okay, so in other terms you can actually say it's the total number of wavelength. So maybe 1.5 wavelength, 2 wavelength, 2.5 wavelength, and in our case just now it's 3 wavelength, and divide by time taken. So extension from this equation is that now we can see that n divided by t actually is number of wavelength per unit time. So number of wavelength per unit time, n over t is number per unit time, number of wave per unit time. That's actually the definition of frequency. Okay, number of waves or oscillation per unit time. So therefore the equation becomes v equals to f lambda, and that's the equation that we are going to talk about today. So v equals to f lambda, okay, actually is derived from distance per unit time. Okay, so where we have the so where we have the v is the speed of the wave fronts, and the f is the frequency of the wave, and lambda is the wavelength. Alright, so now we move on to some example. So we have a, no sorry, we are going to use the PDF, not this one. So first question here, write down for wave q the amplitude. So very easily, wave q would be 2 x naught, okay, because that's the maximum height that it reaches. The period will be 2t naught. The frequency, very simple, it will be just equals to 1 over period, which is 1 over 2t naught. Okay, so because we don't have numbers, so we just put in those quantities. Okay, second, a ripple tank dipole makes 8 water waves in 2 seconds. Its wavelength is 6 cm. Calculate the wave speed v. So v equals to f lambda. So if we think back on what we are talking about just now, the f actually is number, right? So number of waves divided by time. Okay, this is a good example that shows you can calculate in such a way. And therefore we have 8 water wave. The wavelength is 6 cm. You can change it to meter, 10 to the power of negative 2, and then we divide by the time taken, then you should get the answer. Speed of sound is 330. Calculate wavelength of sound wave produced by a violin when the note of frequency of 600. So this one we can use v equals f lambda straight away. So we have 330 equals to 600, and therefore you'll be able to find the wavelength. Okay, so let's move on. Range of frequency of the sound that the human can hear. This one you have to somehow remember is 20 Hertz to 20 kilohertz. Calculate the corresponding range of frequency. Okay, so here I need to tell you that the sound wave is typical speed is about 330 meter per second. Then actually using this sub into the equation for each of the frequency, then you should be able to find the range of wavelength. Okay, then number 5, speed of the light is 3 times 10 to the power of 8. 3 times 10 to the power of 8. Find the frequency of the red light of wavelength 650. So again, V equals to F lambda. You just sub in 3 times 10 to the power 8. Then we have F, once you sub in 650, 10 to the power negative 9, nano is negative 9, then you should find the frequency. Okay, so question 6 and 7 is your assignment question. Alright,